in the camera. We are going to turn it off just in some minutes, but the topic that we want to share with you today is Physics Remote Labs Integration with Moodle. We are from the University of Buenos Aires in Argentina, and here we are. Ema Aveleyra, Diego Racero, and Alberto Villafañe. Hello, everybody.
Hello, everybody.
Hello. Okay, we are going to turn off the camera and just continue presenting. Yes, second. Okay. Well, Ema Aveleyra is the head, is one of the members of the team, the head of the Center of Distance Education, who is also physics teacher and the coordinator of Physics 1 chair. Diego Racero is the media and technology coordinator at the Center of Distance Education, and Alberto Villafañe is a researcher at the SEAD and LEVA, that is a Learning Virtual Environment Center. And some students, collaborators, Nicolás Araya, we have already seen him in the camera, among other people. Okay, we promised in the abstract to talk about the integration of remote labs for physics experiments in a Moodle platform. This work is still in progress. However, we are going to present some conclusions at the end. Some of the objectives of the project is to achieve the integration with Moodle Campus through a booking system that allows the automatic access to the remote lab without any teacher intervention in the organization of the online experience. To use open source elements in the design of both software and hardware in order to minimize cost in the development of experiences. Our presentation will be organized this way. To set you in time and place, we will start with an introduction, then shortly share with the objectives of the project, provide you with a remote lab definition and a description of the layout and components of our lab, as well as the software and hardware decisions we've made. Then the description of the booking system, that will be the core of the presentation. We will describe step-by-step the installation of the EGS system and the configuration of the booking system in the Moodle platform. Finally, we are going to show you some of the experiences in the Physics 1 course and share with you some conclusions. Hola, welcome. Well, just to set you in time and place, in the year 2008, the School of Engineering of the University of Buenos Aires adopted Moodle as the institutional virtual campus in order to offer undergraduate and graduate courses in more flexible modalities. However, experimental courses and activities continue to be offered in massive face-to-face lab sessions. In 2013, we started a research work, an institutional one, with the objective of designing a remote lab for the chair of Physics 1 for the engineering programs. This way, applied basic science teaching could be transformed into an integrated experience, meaning providing the students the possibility of using more experimentation tools that, of course, will be necessary for their professional careers, providing teachers the possibility of interdisciplinary work with other national and international institutions by integrating remote labs consortiums, facilitating university resources management, and of course expanding time flexibility for experimentation, avoiding this way physical space and time constraints. At that time, 2 remote labs started to be designed and implemented. And nowadays, in 2015, some prototype experiences were implemented, and the integration of the remote lab with Moodle Campus was achieved and is still in progress. To start with, with a definition, remote labs are physical facilities where some experiments can be performed with computers controlled remotely over the internet. These labs allow students to learn in an autonomous way, to have more access to the necessary equipment for experiments, and to have experimental activities or experiences focusing on the physical phenomenon through the correct use of software and hardware. Contrasting with the traditional lab that offers practical sessions on a fixed schedule and with a limited time for the completion of the activity, sometimes this time is not enough for the student to complete all the experiences or understand them properly. So time and space constraints in traditional labs can be overcome with the implementation of remote labs. This implementation doesn't involve the replacement of the current infrastructure. On the contrary, remote labs come to complement students' education, providing more access to technology training, providing the opportunity of experimenting with real equipment, and of making decisions with actual experimental data. And also adding the flexibility of time and place to complete them from home or wherever they are. So labs, remote labs in general help prevent students from abstraction of concepts and allow them to have concrete experiences, and also allow them to manipulate equipment, whether locally or remotely, by using internet, webcams, software, specific hardware for getting local data. The main motivation for the implementation of remote labs is precisely the accessibility to a great number of students and teachers, considering that these labs are generally expensive and with restricted availability in terms of time. This is just another way of defining a remote lab, an application based on a client-server environment where clients, students, or researchers from a remote site request services or contact a server through different means of interconnection, internet, which provides the sense of proximity to the lab equipment. Okay, once we analyzed the feasibility of carrying out physics experiences, we got all the components that make up the remote lab, as well as the necessary equipment for internet and image capture, and we integrated them on an aluminium table, especially prepared for different experiences. And in order to achieve interactive experiences similar to those in class, an EP camera was used to see all the actions in the moment they are developed. With an internet connection card, the students can command all the components of the lab with the software interface. Regarding the software decisions we've made, we decided to use the EGS system and Fermata Ethernet. The integration with Moodle is with the EGS application Lab plugin and the EGS booking plugin. The benefit of the EGS plugin is that the integration with Moodle platform and the booking system is already designed. In fact, a Spanish university designed this plugin, the Universidad Nacional de Educación a Distancia, de UNED. The Fermata Ethernet connects the EGS plugin to a microcontroller board that allows the serial connection with internet, and the dark code in the remote lab. Regarding the hardware decisions, remote labs at the University of Buenos Aires use Arduino boards and Arduino software. You know that these are open source components, and EP digital camera, and of course particular mechanisms or particular technology for each remote experience. That is to say, complementary hardware to Arduino. Another important part of the implementation of the remote lab is the booking system. To operate the lab, it is necessary to make a reservation on a specific date and time. However, students can repeat the experiences as many times as they need it with a new personal or group reservation. The EGS plugin has the ability to interact with the reservation system and authorizes the entry to those students who have made the reservation, meaning the entry to the remote lab. So when somebody tries to enter the remote lab, the system checks the reservation agenda. So if the student or group is within the date and time reserved, they are allowed to start the experience. Otherwise, the entry is denied. So in the following slides, we are going to describe in detail this step-by-step installation of the EGS plugin in Moodle and the configuration of the booking system in the institutional Moodle campus. Afterwards, we will share some details of the experiences and their development. One is about light diffraction, and another one is related to mechanical resonance with the Coombe tube. Well, then we will tell you that both experiences are obligatory practical assignments in Physics 1. Okay, are you following us? Okay, are you understanding our English? Since we are just Spanish speakers, we are doing our best. Yes. I will pass the microphone to Alberto Villafañe, who will explain this step-by-step implementation.
Well, I try to explain how to install some components to manage remote laboratories from Moodle with booking system. First, let's take a look at EJS app and booking system plugins download. Here is the page, and we can see the buttons to do the download. So let's start downloading the EJS plugin. We just need to click on the download button. When the download is complete, here we can see we open the container folder and save the EJS app file in the hard disk. Also, we save the EJS booking system file the hard disk. Then we open the folder containing both files. Here they are. And also open the map folder within our Moodle installation. Which contains the modules of our Moodle system. Then we place the AJS app and EJS booking folders into the Moodle folder within Moodle. And we wait while the files are copied to the Moodle folder. Here we can see. And still waiting. And we have the two folders in the map folder of Moodle. Now we are back to our Moodle experimental installation. It will find the new plugin. To complete the installation of the EJS app and the booking system, click on Upgrade Moodle Database now. And then click on Continue. So, Moodle database has been updated. And now we can change some settings, if needed, of course. Now we can go back to our Moodle course called Remote Laboratory CEAD. Let's see how to add a remote laboratory created with AJS into Moodle using the AJApps module. We start with an empty Moodle course. To add content to this course, we need to activate the editing mode on. Now we can click on one of the Add Activities or Resources buttons and choose the EJS App activity here. And then fulfilling the form for adding one of these activities. We just need to write a name for the activity here and select the AJS file. This jar file has been previously prepared, so we can now just pick it from the hard disk and put it here. And here is it, the jar file of the remote laboratory. Of course, we want to use the EJS app booking system with this lab. The remote lab configuration menu in the form allows setting these properties for that purpose. First of all, we need to specify that this is a remote laboratory by setting to yes the remote experimental system field here. This will allow the EJS app booking system to manage the access of users to this activity. Now, the IP and port fields should contain the information of the computer controlling the remote laboratories. This lets the EJS app booking system to check whether the remote laboratory is present or not. For this presentation, we are using IP 127001 and port 443. EJS app allows fixing a maximum number of hours of work for every user. These parameters can limit the total, daily, and weekly maximum hours of work. Why? This prevents users from making massive bookings which may even be unused. Here is it. Our remote laboratory has been added to our experimental Moodle course. Let's take a look at it. Here is our EJS application embedded into Moodle. Now we can go back to our Moodle course, which we previously called Remote Laboratory CEAD. Here's the remote lab example we added to this Moodle before. Let's now add the EJS booking system instance. We can add it here as a resource and then add it. And here is the EJS booking system instance added. First, we need to select the remote laboratory for which we want to make the booking. We can see this menu. Note that the booking system has identified the current user here. Also, note that we can select the users who will be granted permission to make bookings. We choose an hour for the selected date and press the Book button. So we confirm the booking and we are done. This is the end for the step-by-step presentation of the installation of the booking system.
Okay. We are back after this step-by-step presentation. There is a question here if this is a Java applet, and the answer, can you write the answer in the chat box? Yes, it is. The answer is that yes, it is. Okay, let's go on with some of our laboratory experiences. Two remote laboratories were designed to study the phenomenon of light diffraction and mechanical resonance. I see that there are some questions. After we finish the presentation, we are going to answer all these questions again. Two remote labs were designed to study the diffraction of light and the mechanical resonance. In the first case, the goal, in the case of light diffraction, the goal is to obtain an image of the diffraction pattern and characterize the diffraction network, having the laser wavelengths and the distance between the network to the screen by using the free software tracker that allows students to analyze the data obtained. Yes, we can see here just an image of the part of our lab that works on that. The lab experience consists on connecting to the internet using the Arduino interface with a relay module that allows the laser light illuminating a diffraction network. The obtained image pattern is watched by the student through a video interface, and the video is obtained by using an EP camera. In the second remote lab, the phenomenon of resonance is analyzed and studied, and the speed of sound in the air is obtained by using a cold tube. For this experience, a DC motor and the mechanism of an old CD player was recovered and used. A DC driver, a discontinuous current driver, that allows the Arduino board to handle the high voltage of the CD player mechanism is used to move the piston into the cold tube. An audible signal generated by a digital output in amplified PWM format is injected. The signal values within the tube are and with the microphone. The signal captured by the microphone is plotted on the user's screen using an open API in JavaScript known as a float. Okay, you have an idea of our first two experiences, and we are going to share with you some conclusions. Some of the conclusions are related to the achievements. I mean, 2 prototype experiences have been implemented in undergraduate courses of Physics 1, and we are currently implementing improvements. The second achievement is that we formed a group of motivated teachers, researchers, and even students with different educations and formations who work with other colleagues here at the university, coming from other areas of specialization, and also with colleagues from Spain, who are the ones that developed these plugins for Moodle. And we share designs, processes, and results. Other conclusions are related to the new lines of work. The new lines to complement the implementation of remote labs at the university. One is the incorporation of robots for assembling the lab systems. The second line is to continue designing new physics lab experiences, for example, one with a pendulum, etc. And the last line is to get the integration of remote labs with the booking system in Moodle, but with fully open source hard and soft. Our remote lab is modular and with an open architecture that has multiple possibilities of expansion, such as incorporating new experiences. New developments with open source components are in progress. The design and implementation of remote labs for us have many positive aspects, but we want to highlight a relevant dual function. a social function since they make possible to share resources, equipment, and scientific results with other national and international institutions, and an economic function since costs of implementation and maintenance are drastically reduced. Okay, that's it. Thanks for attending the session, and we are here for your questions. We've seen that you have written some, yes, and well, I hope you find it interesting. For us, it's really motivating, so hope you share this interest. Okay. So we are here for questions, but if you want to send some questions by email, we are going to write our email addresses in the chat box.
Well, I want to thank you for a great presentation and for really encouraging, I think, greater collaboration, especially when there are limited kind of physical resources like labs and things like that. As I was listening to you, one thing I started to wonder myself was with the Jesuits and our role with the Vatican Observatory, how those facilities can be used and made more readily available to students around the world. And I think you've kind of started to show some ways that can be encouraged and promoted. So thank you for doing that.
Yes, that's it. We are part of Remote Labs Consortium. There you can find really remote experiences for different areas, not only physics experiences, sometimes mechanical, electronic, connected with electronic engineering, mechanical engineering, that really we share every advancement of remote labs, and that is really motivating and useful, because sometimes we can have experiences that we haven't already designed and some other university did, so it's a really interesting way of working.
Yep, excellent.
We are answering some of the questions written in the chat box. Nada has some questions, and Alberto is answering. And Ema?
Yep. Emma, it might be helpful if you read the question and then read the answer to the question, just so that those are available on the video recording.
Okay. The first question was if, let me go back and see if I have the question and the answer. Let me see. Your first answer is this. Exactly, that's the idea. HTML5, JavaScript, C++, and Ajax is used for
interchanging data.
That's it. That is one of the questions. What is the technology we use for exchanging data? And we explain HTML5, JavaScript, C++, and Ajax. Another question. Is it still available on the market? No. What are you referring to, available on the market?
To 2001
Space Odyssey.
Oh my God! We wish we have that one.
As a way to compare with the last remote.
That's it. It's remote and robotic, but not that far.
Like a whole 9,000.
That's it, like whole 9,000. But well, for our students, it's really very interesting, yes, to have the possibility of trying as many times as they need the experience that sometimes is not possible in lab sessions, because imagine that we have 80 and 100 students in one physics, in one course. Yeah, so these are very big groups, and the time allotted for the experience sometimes is really short. Yeah, so having this remote lab possibility that they can just have a new experimental data to analyze, from home, from the university is really useful. Is there another question? No?
Another question, please ignore.
Please ignore the final question. Okay. We can just copy the website where we got the EGS plugin if you find it useful. Or as I told you before, if you have any other questions, just send us an email. And Anthony, you tell us how to go on.
Okay, well, I just want to thank everyone for attending the presentation and thank Emma and your team for sharing with us your ideas and your experiences about how to get labs, working together and how to really promote greater collaboration, I think, in a classroom. So thanks for a great presentation. I'll go ahead and turn off the recording at this point.
Thanks all to